Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a question on similarity, and I'm going to get straight into it. They've said to us in triangle NML, which is this bigger triangle over there, P and Q are points on the sides, MN, which is that line over there, and LN, which is that line over there, respectively, such that QP is parallel to LM, and they've marked that in for us. They've also said to us that MN is equal to 16 centimeters, so that long line over there is equal to 16 centimeters. They've said to us that QP is equal to 3 centimeters, which is that line over there, and LM is equal to 8 centimeters, so that's that line over there. Now they've said to us complete the following, give reasons for the statements. They've said to us prove with reasons that triangle QPN, so QPN is this one over here, is similar to triangle LMN, which is this one over there. Now, when it comes to proving two triangles are similar, there are two ways to do it. The first way is to prove that all of the corresponding angles are equal to each other. The other way is to prove that there is a constant ratio between the sides of the two triangles. Now, in this case, it looks like they want us to prove that all three sides are equal to each other, because they've already set the question up like that. So let's get into it. In triangle QPN and triangle LMN, the angle N is equal to, so we've got over here, N. Okay, do you notice that N is common in both triangles? So N is simply equal to N. Okay, you would actually just need to write N, but because they've given us a space to write, we'll write N, and we will say that it is common. So it's common to both of the triangles. Moving on to P1. So we've got P1 over here. Which one is that equal to? Now what's useful is we've got these parallel sides. And you see we've got this backward F that's sitting over there. So that would mean, and I'm going to change my pen color just so it's clear, that P1 is equal to M. Why? Because we've got parallel sides. So P1 is equal to angle M. And that is because of corresponding angles. Now, it's not sufficient to say that. We need to say which lines are parallel. And we know that LM is parallel to QP. Brilliant. Moving on to our very last one. I'm going to change my pen color again. So they've asked us for Q1. Okay, what is equal to Q1? And very similar to the previous one, we can see that we've got a forward-facing F, which means we have Q1 equaling L. So I'm going to change my pen color back. So Q1 is equal to angle L, and that is because corresponding angles are equal, and we know that lines LM and QP are parallel. So that means that triangle QPN is similar to triangle. So we need to write the triangle in the right order. So we can see that Q is equal to L. So that means the L would go first. We then see that P is equal to M, which will then go second. And we can see that N is common, which would make sense that N would go last. And the reason here is angle, angle, angle. You could also write it as angle, angle, angle. Nice and easy, all of the marks given to you. Really good, guys. Moving on to the second part, they've said to us, hence calculate the length of PN. And remember, this word hence is super useful because it says that there is help in the question before. So they've said to us, hence calculate the length of PN. So I'm going to change my color pen just so we know which one we're looking for. We're looking for PN. Now they've said to us hence, which means we need to use the fact that the two triangles are similar in order to prove this one to be true. Right, so we're looking for PN. So let's mark PN. So we've got PN over here. Okay, so PN is the one we're looking for. What other lines do we have? Well, we've got LM, which is 8. So I'm going to put a little marker over LM. We've got QP, which is this one over there. And we've got MN, which is this one over here. Okay, so let's put that now into a single mathematical statement that is going to be useful for us in order to solve Pn. So we know because our triangles are similar, there's going to be a constant ratio between the corresponding sides. And the corresponding sides here are the QP and LM and the PN and the MN. So let's write that out. So we know that QP over LM is equal to QP over LM is equal to PN over MN. Okay, so we've got a constant ratio between the corresponding sides. That's the first step. Now we can plug in our values. So we know that QP is equal to 3 centimeters. We know that LM is equal to 8 centimeters. We don't know what PN is, so we can write PN again. And we know that MN is equal to 16 centimeters. Now we need to solve for Pn. And what we would do is we would times both sides by 16. Okay, so to cancel out that side, we would times by 16. But because it is a equation, we need to do the same thing on the other side. So it would be 16 times 3 divided by 8. And that's going to give us an answer of 6 centimeters is equal to Pn. And that is the final answer. Very special thank you to our sponsors for making this video possible. Remember to check out our website for more of these epic tutorial videos. If you can't find the video that answers your question, remember to send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.